Now in this lecture, we are going to create deletion of a node method in CircularDoublyLinkedList class, and we are going to create this method based on the algorithm that we have explained in our previous lecture. So I'm going to declare our method after the search node method inside the CircularDoublyLinkedList class. So our method name will be delete node. So I will declare method like this: public void delete node. Then this method will take one parameter, which will be the location parameter. Now based on this location parameter, we are going to identify from where we need to delete a node from CircularDoublyLinkedList. Now the first thing that we are going to do, we are going to check if head is equal to null or not. So if head is equal to null, this means that our CircularDoublyLinkedList does not exist. So we are going to print out message to the console saying that the CircularDoublyLinkedList does not exist. So the CircularDoublyLinkedList does not exist. Now with this we are terminating our algorithm over here. That's why I'm going to put return over here. Now otherwise I'm going to check location parameter to see from where we want to delete a node. So else if location parameter is equal to 0, it means that we want to delete a node from the beginning of CircularDoublyLinkedList. So this means that we need to delete first node from CircularDoublyLinkedList. Now, as you remember, when we are discussing the deletion of a node from the beginning of CircularDoublyLinkedList, we said that we have two cases. Now, the first case is if we have only one element in our CircularDoublyLinkedList. So how can we check that if we have only one element in our CircularDoublyLinkedList? Now, if size is equal to 1, in this case, it means that we have only one element in our CircularDoublyLinkedList. So this means that here we have to set all references to null. So I'm going to set head.previous to null, head.next to null. So we are setting previous and next references of first node to null. Then head and tail references should point to null also. So I'm going to set both of them to null. Then at the end we have to decrease the size by 1, because in this case we are deleting one element from the CircularDoublyLinkedList, so the size has to be decreased by 1. So then we are going to return over here. Now in the else condition, we are going to write the case in which we have more than one element in our CircularDoublyLinkedList. So if we have more than one element in our CircularDoublyLinkedList and we want to delete first element from this CircularDoublyLinkedList, the logic will be like this. So we have to create a link from head to the second node. So to do so, I'm going to set head next to head, because by accessing this we are accessing the next node, second node. Then we are going to create a reverse link from this new first node to the tail. So I'm going to set head previous to tail, and this creates a link between second node and last node. Then we have to create a link from last node to this node. So I'm going to set tail.next to head. With this we are creating a link between last node and second node, because second node will be the first node after deletion of the first node from the CircularDoublyLinkedList. Then at the end we are going to decrease size by 1. Now with this we have successfully implemented logic in which we want to delete a node from the beginning of CircularDoublyLinkedList. So in the first part of if condition we have implemented for the case in which we have only one node in our CircularDoublyLinkedList, and in the else condition of this if condition we have implemented the logic in which we have more than one element in our CircularDoublyLinkedList. Now let's continue to the next case in which we want to delete a node from the end of CircularDoublyLinkedList. Now else if location parameter is greater or equal to size, this means that we want to delete an element from the end of CircularDoublyLinkedList. So here again we have two cases. The first case is in which we have only one element in our CircularDoublyLinkedList, and the second case is we want to delete last node in which we have more than one element in our CircularDoublyLinkedList. Now when we have one element in our CircularDoublyLinkedList, the logic will be the same as we deleted from the beginning of CircularDoublyLinkedList, because here we have only one element in our CircularDoublyLinkedList, and this means that this will be the first and last element. So here I'm going to implement the logic that we have implemented over here. So what I'm going to do over here, I'm just going to copy this code from here and paste it over here, because in this case the logic is same. Here we are setting previous and next references of first node to null and head tail to null. Then we are decreasing the size by 1. Now then in the else condition I'm going to implement the case in which we want to delete last node where we have more than one node in our CircularDoublyLinkedList. Now here the first thing that we are going to do, we have to create a link from tail to the second last node. So to do so I'm going to set tail previous to tail. Then the next step is we have to create a link from the second last node to the first node. So as you see, we have set tail previous to tail. So if I set head to the tail next, in this case, we are creating a link between the second last node with the first node, and first node has to point to this node also. So I'm going to put like this: head previous will be updated with the value of tail. So with this, we are creating a link from first node to the last second node. Now, after doing this operation, the current last node becomes eligible for garbage collection. So the garbage collector comes and deletes this one from the memory. So we have to decrease the size by 1. Now in the else condition, we are going to implement the third case in which we want to delete an element from any given location in CircularDoublyLinkedList. Now here, the first thing that we are going to do, we are going to create a temporal node, which will be the type of Doubly node, and this temporal node will take the value of head, because we are going to loop through the first node until we reach the location -1. So after doing so, we are going to create our loop like this. So loop will start from index of 0 until it reaches the location -1, and in each iteration it's going to be increased by 1. When in each step we are setting temp node.next to the temp node, because in each iteration we are continuing to the next node. Then when we reach this location, which is location -1, we are going to create a link from the current node to the node that comes after the next node. So I need to set current node's next reference to the node that comes after the next node. So if I access temp node.next.next, we are accessing the node that comes after the next node. Then we have to create a reverse link from this node to the temporal node. So in this case, current node is temporal node. So if I access temporal node's next reference and previous reference, then in this case, we are accessing the previous reference of the node that comes after the next node. Then we are going to set it to temp node, and this creates a reverse link between the node that comes after the next node and the current node. Now with this, we are deleting the links that goes to the next node. So next node becomes eligible for garbage collection. So we can successfully delete this node from the memory. So then we are going to decrease size by 1. Now with this, we have come to the end of this method. So here we have combined all 3 cases of deletion in one method, and based on location parameter, we can easily identify from where we can delete a node from the CircularDoublyLinkedList. Now let's see how this is working in practice. Now here we have created a CircularDoublyLinkedList like this, and then we have inserted 3 more elements to CircularDoublyLinkedList. Now in our CircularDoublyLinkedList, we have 4 nodes. So then I'm going to call traversal method to see the CircularDoublyLinkedList in the console. Then I'm going to call delete method. So first we are going to delete first element. So that's why I'm going to call this method with the parameter of 0. Then after calling this method, I'm going to print out to the console one more time our CircularDoublyLinkedList by using traversal method. So with this, we can easily see the differences between before deletion and after deletion. So let's run our code. Now you see that initially our CircularDoublyLinkedList was like this. Then after deletion, the first element, which was the 2, gets deleted. So our CircularDoublyLinkedList becomes like this. Now if I run this, for example, with the value of 6, in this case, 6 is greater than the size of CircularDoublyLinkedList, it should delete the last node from the CircularDoublyLinkedList. So in this case, you see that initially our CircularDoublyLinkedList was like this. So the last element is 4. So after deletion, 4 disappeared from here. Now if I put, for example, index of 2 over here and run our code, now in this case, you see that at the index of 2, we had 3. Now after deletion, it disappeared from here. Now our method works the way that we want. Now let's see what's the time and space complexity for this method over here. Now as always, we are going to start first line of this method. In the first line, we have if condition in which we are checking head is equal to null. Then we are printing out to the console saying that the CircularDoublyLinkedList does not exist. So this part of code will take a one-time complexity, because in this case, any time consuming operation is not performing over here. Then in the else if condition, we are checking if location is equal to 0. Then inside this if, we have another if in which we are checking if the size is equal to 1. Then we are updating the previous and next references of head, and we are setting head and tail to null, and the size decreased by 1. And this part of code also will take a one-time complexity. Then in the else part of this code, we are updating the head to head next and head previous to tail, and tail next to head, and size is decreased by 1. So these are just simple assignment statements. So these will take a one-time complexity. Then in the else if condition, we are checking that if the location is greater or equal to size. So this is also will take a one-time complexity. Then inside this if condition, we have same operations that we are performing over here. So this will take a one-time complexity. Then in the else condition, one more time we are updating tail and tail.next and head previous and decrease size by 1. So this part of code also will take a one-time complexity, because in this case we are just updating the tail references and head references. Now when it comes to the else condition, here we are creating a temporary node and assigning head value to it. So this line of code will take a one-time complexity. When it comes to this loop over here, in the worst case, we have to traverse through the CircularDoublyLinkedList until we reach the n-1. So -1 is the constant term over here, so we can eliminate it from over here. And this loop over here will be n-time complexity. Now inside this loop, we are setting temp node next to the temp node, and this will take a one-time complexity. Then at the end, we are just updating temp node's next reference and temp node's next and previous references and decrease size by 1. So this part of code also will take a one-time complexity. Now if we combine all these complexities together, we are getting n-time complexity, because here O1s are non-dominant terms, so we can easily eliminate them, and we have left with n-time complexity. Now the space complexity is O1, because in this case an additional memory is not required to perform this operation. All we are doing is we are deleting one node from CircularDoublyLinkedList. Now with this we have come to the end of this lecture. So in this lecture we have combined all three cases of deletion in one method, and based on location parameter we can identify from where we want to delete a node from CircularDoublyLinkedList. And at the end we have learned what is the time and space complexity for this method over here. Now hopefully everything is clear about this method. I'll see you in the next lecture.